right, thanks everybody. We're really happy to have you here for tonight's showcase. We're going to be looking at the thoughtful rebuilding after a devastating fire season with B.Public, and can't wait to get started. First, we're going to share a little message from David Attenborough. So let me get this shared correctly here. I have to go like this.
A new industrial revolution, powered by millions of sustainable innovations, is essential and is indeed already beginning. We will all share in the benefits: affordable clean energy, healthy air, and enough food to sustain us all. Nature is a key ally. Wherever we restore the wild, it will recapture carbon and help us bring back balance to our planet. And as we work to build a better world, we must acknowledge no nation has completed its development, because no advanced nation is yet sustainable. All have a journey still to compete, so that all nations have a good standard of living and a modest footprint. We're going to have to learn together how to achieve this, ensuring none are left behind. We must use this opportunity to create a more equal world, and our motivation should not be fear, but hope.
Can we fix climate problem in one generation? My answer would be yes, we have to.
We need to not just to talk about what we can do, but to do what we can.
This is a challenge that we should try to solve in a quick way with a long-term vision.
It comes down to this: the people alive now are the generation to come. Will look at this conference and consider one thing: did that number stop rising and start to drop as a result of commitments made here? There's every reason to believe that the answer can be yes. If working apart, we are force powerful enough to destabilize our planet, surely working together, we are powerful enough to save it. In my lifetime, I've witnessed a terrible decline. In yours, you could and should witness a wonderful recovery. That desperate hope, ladies and gentlemen, delegates, excellency, is why the world is looking to you and why you are here. Thank you.
Okay, I think everybody is back, so let's dive into the program now. I have the distinct honor of welcoming the team from B.Public for tonight's presentation. So I'm going to do that right now. Edie Dillman is CEO and co-founder of B.Public Prefab, a component-based high-performance building company that prioritizes energy reduction and housing creation. As co-founder of a decidedly disruptive company, she's committed to systems change and the rapid adoption of solutions for the natural and the built environment. Jonah Stanford founded the design firm NEEDBASED Inc. and is CTO and co-founder of B.Public. Jonah joined the first generation of Passivhaus Consultants trained in North America in 2009, and his work typically targets site net zero energy and incorporates his enthusiasm for building science and material science applications. Charlotte Lagarde is COO and co-founder of B.Public. After 25 years in advocacy work, Charlotte brings her passion for systems change to B.Public to address climate and housing issues, and returns to her first love of architecture and the built environment with B.Public. Prior to B.Public, as the executive director of the Swell Foundation, a nonprofit corporation she founded in 1998, she produced over 20 films and raised millions of dollars. J.D. Scott is lead architect at B.Public and an emerging leader with nearly a decade of experience in the movement to tackle climate change and the affordable housing crisis. JD has also worked in architectural practice at multiple scales, from single-family homes to complex multifamily developments. So with that, B.Public, please take it away.
Thank you so much, Zach. Lovely intro. Great to be here. We're really excited to share a little bit about what we're doing, and really fun to use a live case study tonight to walk you through what B.Public has developed and how we approach passive house as well as prefab. We're going to walk through. I'm going to intro first JD Scott, who's the lead architect. Charlotte Lagarde was actually the project manager on this, and she's going to jump in at the Q&A as well. And Jonah is both CTO and architect. I think some of you know Jonah. He's wearing a really excellent B.Public t-shirt. Here, quickly going to make my t-shirt a B.Public t-shirt.
It's like actually all I wear. I'm just so appreciative of having a uniform.
There we go. So we're just really delighted to share this and excited for the Q&A. It's always great to have a conversation about this, and we'd love to jump in. So JD, you can take it away and share screen.
Great.
Looks great.
Well, everyone can see. All right. I'll just pause it here for a second. We have this lovely GIF that scrolls through us, so we can all kind of get mesmerized by this for a second. Thanks for the introduction, Edie. Just to give you some context on the project and kind of the background. This is a rebuild from the CZU fire, which was a major wildfire event back in 2020 in Northern California. And Santa Cruz County was really the hardest hit in that event, losing nearly 1,000 single-family homes in the fire. And so our client had lost their home in the event, and were really excited to return and rebuild. But this was a really traumatic, event for this community, and that's something that we all experienced when we were on the ground there in September. Santa Cruz County has really rigorous pre-clearance requirements for these rebuilds, and so that was on the front end. Our client really had to do a lot of work to even be eligible to do this. This is an image of the site, kind of in the aftermath of the fire. So you'll notice kind of some debris has been cleared, and they've scraped and started kind of the excavation process, and you can see the erosion controls in place on this project.
You can see this actually. Sorry.
Jonah is going to give kind of an overview of the B.Public system and its attributes too.
Thanks, JD. And I just JD's been so much fun to work with on this. And just sort of a note quickly. So this project, these clients approached B.Public in February. And we installed, I guess, about a month and a half ago. Mm-hmm. And so just JD is responsible for, onboarding those clients, finalizing the design process, and then getting those CDs, with offsite construction through permitting and so forth. Thanks, total shout out to his abilities there. So, it was a really good, case study for the B.Public components, because it really had a little of everything. It's a little bit of 2 stories. It's a lot of seismic. It's a little bit of slab, insulated slab. And so it really did test some of the resiliency within the design of the offsite standardized components in a lot of ways. And then also just being in a C3, like a coastal climate range also. So, all the components are designed, with best practices that we've learned over the last decade around passive house, right? So it's just, insulate as far as you can go until that there's a reduced return to it. But really your greatest, long-term gains come from good building science of, eliminating your thermal bridges and in ensuring your airtightness is going to be on target and so forth. And so the B.Public components, I think, maybe most people are familiar with them here, but so they are primarily carbon sequestering. They are thermally bridge free, even if they're all their connections. And so it was really great to see JD take on this project with the components and see how they did from a structural and a seismic perspective. Because really our focus has been, see if we can take those best practices and generate something that was really resilient in terms of its climate, its seismic or structural loads that are always defined per project, and see if it would work within these really diverse situations. So it was a really great project in that way. And I'll just give it back to JD for process there. And we'll have lots of time for afterwards for questions to get into more technical if people want.
Absolutely. Oops. So yeah, moving kind of more into the design process, B.Public, the way we structure our project phases is we start with a kind of site evaluation, site sketch phase, and we also provide a preliminary 3D model at that phase using the components that Jonah just outlined. And it's really just to give a client, that first vision of what could be done on a site. And so, so in this case, we're showing that dash line where the original building was, and then locating, the new house on the site. Particularly important now for these rebuild projects is having a pretty beefy fire suppression system. So you'll notice the tanks that we've located on the site plan. And we also look at other, site elements they might want to incorporate, like a garden or things like that. And this project was oriented for a PV array, but it's also on this really wonderful axis with a view towards the Pacific Ocean that you can see on clear days when you're out there. And kind of the second half of this phase is, like I said, is generating this component model. And this is all using our standard panel components, which we have in SketchUp. They're available for download for free. So anyone on this call could download these and experiment with them. But it's a really intuitive way to design and to create a thermal envelope really quickly. This newest generation of SketchUp components are true to life, so they have all the information that our shop drawings would have for the panels. So you can see all the structural framing and the interior and exterior furring strips are on these. So it gives the client a ton of detailed information up front that, in a normal architectural process, you wouldn't encounter this until, DD sometimes later. And accompanying this, we give the client a detailed panel estimate. And so this gives them, options up front if they want to look into financing or talk with a builder. They have a lot of leverage coming out of this first phase, just from this from this panel model. Jonah, I don't know if you had anything to add on this.
No, I think we can probably go on to the other slide, but during that site plan design, and then this sort of the model building happens really side by side, so that the client has a good estimate for that total thermal envelope construction cost. And one thing that JD and I pay attention to is that once you've got your performance nailed down and the cost of it, then it's around 35% of your total construction costs, where the remainder is really a tool in terms of finishes and amenities that a project can undulate its budget to. So it's really nice to have that level of cost estimate for the thermal envelope at this point. So,
yeah. And kind of moving into our next phase, we get more into the kind of architectural expression of the project. So we, in this case, we're giving the client different, fire-resistant finish options. That being said, we really try to leave these decisions to the client and builder, because our primary focus is really on the system performance and those kind of critical items like the panelized assembly, like windows and doors, the ventilation system, ERV system. And so in our builder set, our construction documents, we developed those critical items in an extremely rigorous kind of detailed way. But we let the kind of fun decision-making fall onto the client and builder. So again, that kind of opens up some more flexibility for our clients.
Yeah, and a lot of these are done. This is all done on an iPad.
Yeah.
So this combination of the aesthetic being defined like on an iPad and traced like really light, and then the other like the 3D modeling, before it goes to a BIM or construction documents. So you have like really accurate passive house detailing, like building science, thermally bridge understanding, and a fun sketch of what it's going to look like on the outside. And it's kind of cool that it really works from both sides. And then the next step is where that BIM comes together for coordination. So.
Yeah, which again is kind of flipped from the normal architectural process, where these types of drawings would be extremely developed, and then all the system stuff would be complete question mark. And so then we move into the developing the construction set. One of the ways that we're really streamlining this is by developing a standard detail of, a standard library of our details. So our panel connection details, and also site built details. And these are kind of vetted ahead of time, and we're able to run them by the engineer of record and develop them on a project by project basis. And at the same time, we're thinking kind of ahead towards the actual panel install. So this image on the right, it was included in the construction document set as kind of an aid to our install crew, when they were on the ground, installing the project. And the other kind of main thing we're tackling with our construction sets is we're hopeful as a company that prefab is going to become the norm in terms of construction. And with that comes, it becomes really important to understand and delineate scope of work. And so at the beginning of all of our construction sets now, we have this project navigation page, that drawing on the right, that kind of establishes what the different scopes are, and really serves as a communication tool to the builder, indicating what needs to be done before the panels arrive, what scope B.Public is providing, and then everything that would come after that. And I think it helps more and more as we're partnering with other architects where we're not the architect of record. It helps kind of communicate to them how that scope is divided up and what those responsibilities are.
Yeah, and for those of you that are lucky enough to work on full modular projects or multiple family projects, then this becomes less critical in a way, because there's the coordination is happening all within house. But where B.Public is really working on trying to serve smaller projects or more rural projects that are not having the level of access to full modular or larger of a scale project where the whole project is being prefabricated. So working on ways how we can clearly integrate with local architects and builders in that way, and serve smaller projects just as efficiently as the larger multiple family or larger projects are utilizing offsite construction.
Yeah. And once the building permit is issued, we can start with panel
or maybe
fabric.
a little bit before the permits issued.
Right. Ideally, yeah. We could start with panel fabrication. So these are some images of the panels being constructed in this shop.
I do want to jump in here really quickly.
Sure.
So we did actually, components were being manufactured, and at the last minute through permitting, one of the, the consultants for the plan reviewers was like, no, you need independent testing on everything. And so we did have to, like, it was a, just talking about the process. It's, one thing that we really learned is very important for us to engage with that jurisdiction very early on, and everybody to be on board. And once they understood it, then it was totally fine. We were good to go. But there was some funny moments. Right? Yeah,
no, that was a good that's a good point. But yeah, these are just images from the shop. I think what's great about the system is that it's constructed very intuitively. It uses pretty standard tools that all of us are familiar with. So it's not reliant on automation or anything like that. And it's built obviously in a really controlled environment. So this is kind of what it looks like as the panels are being fabricated and before they're kind of trucked out to the job site. I don't know if you had anything to add on this one, Jonah or Edie or Charlotte.
No, I think Ian at Collective Carpentry would probably laugh at saying it was in a super controlled environment.
So once the panels are complete, they're brought to the job site. These are just some images from the first couple of days of this install. I think in total, the panel install was less than a week, and then plus some extra days for air sealing and the taping of seams and things like that. And this video kind of shows some of that. I think what's another kind of hallmark of the system is that the install crew is pretty small. I think this was done with a crew of 4 or 5 and a crane, and that's it. And it is, I think for all of us, it was really exciting to see the system tested and implemented this way and this quickly. I don't know if you all had other thoughts on the install.
No, I just think like one of the, we might see another picture of it, but one of the hallmarks of the B.Public assemblies you can see is where you were being able to, like, the organization or sequencing of loading and unloading the panels. And I actually wasn't there at the very beginning of this project, but came in after the walls were all set and so forth. But just being able to have all your components stacked in one place, and all of your roofs that are identical and they're not 100% project specific, it can just really ease this portion for mobilization and offloading. So
just some images of the interior. I think we definitely use the installs as an opportunity for community building. So we really encouraged during this project for neighbors and just passersby to hang out on the job site, and there was just a lot of excitement, I think, around someone rebuilding first of all, but also someone really rebuilding with such an innovative system. And I think the speed of it really just inspired people in that neighborhood. And we also use it for educational purposes. And so this is an image of a larger group of architects, designers on site who toured the project. I can't remember the total number of people we had who came out to see it, but it's a great opportunity for people to see the system, to see the different connections, and even for clients and people who aren't as interested in the technical side. They get to see really early on, I think, how the spaces are shaping up and how it feels to be in some of the spaces. So yeah, it's a really good, I think we treat each build as a really good opportunity for that.
Yeah, I think there was probably at least 150 people through this in the 4 days that I was there, like that.
Right.
But that picture in the lower left is like from like you saw in the SketchUp video of like the components being sort of dragged in place. And then it's really on site, you're actually able to see those same components with the install crew, like craning them over and placing them. And it's amazingly similar to the SketchUp drag and drop. But you can actually get a really physical understanding of how to create the rough openings using the different filler panels. And it just gives a lot more sort of intuitive understanding of it when designers are then doing it from a digital side or a design side.
Yeah. And I think just another quick video from the one of the open houses we had on the project. But yeah, it just generated, I mean, I feel like I've talked to dozens of people when I was out there, and it generated a lot of interest and excitement. And I think that's it. Feel free, if other B.Public folks, to chime in if we need to backtrack, or if you wanted to add to that, but I think that's it.
That was fantastic, you guys. It's really fun to share it and to have you guys walk through it. And it's a nice place to end on that slide or the video of the open houses. We did 2 public or semi-public events, and on the Thursday evening, the event went, I think, 3 to 6, and it was a lot of neighbors, but it was also a lot of builders. As you can imagine, in a rebuild neighborhood, there are a lot of pickup trucks, a lot of activity. And I have to say, a lot of grateful neighbors that didn't lose their homes, who really were happy to celebrate with their neighbors. As you can imagine, the folks, it's especially on this street, it's very random. You know, it's 2 houses that are totally gone and then 3 that are still standing. So to gather with the neighbors was pretty incredible. But, you know, this evening is the continuation of those open houses, is taking opportunity to pause and walk through the building and talk about, you know, especially in this community, I think, you know, what are the learnings? What are we changing? What are we taking opportunity with to make it better? But also calling other folks into this conversation and sharing what's going on in building science, and, you know, moving to carbon sequestering and speed, and getting people sort of informed, either very casually or really doing long tech walkthroughs with the team. So thanks. That was really beautiful to see you guys. Thank you.
Well, and Zach, I just want to say that video that you played right before was amazing. It was a really great. It was really inspiring. It was really great. And I just thank you. Yeah, it was neat.
Well, credit to Sean for suggesting that we play it. There's some really, I mean, you know, there's good stuff happening at COP. I mean, yeah, I know all of us are very, very eager for it to happen faster, but there's been some encouraging signs. This is great. Maybe I'll just take a moment to thank sponsors. Yeah, so everything we do at the Accelerator, as folks know, comes thanks to these organizations who support our work. So big thank you to our founding sponsors: 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwool North America, Stillcorp, and Zola Windows. Our champion sponsors are Icon Windows and Doors and SIGA, and our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Thanks also to our patron sponsors: AeroBarrier, BR+A Consulting Engineers, Brennan Air Tightness and Insulation, Euroline Windows, Inotech Windows and Doors, Lamelux, Sanderson Sustainable Design, and U.S. Engineered Wood T-Stud. So thank you, sponsors.
All right, everyone, I am remote, so I have gathered the list of individuals. So we have in the queue, we have Jeff, Mackenzie, Scott, Sean, your question was answered. Kevin, Andreas, Steve, and Ian. We'll get to that. But just a couple of points I want to start off is I think it was great to see and discuss the team culture that you're creating. Again, that's important for all of our organizations. Oh, hold on one second, Mackenzie. We'll get to your question in a second. Again, check out the free downloads that B.Public had in the link. So for all of you, save the chat so that you're able to access all those or copy and paste now. And this project reminds me of something that I read many years ago. There used to be a magazine called The Automated Builder. And if anyone recalls that, you're a bit of a dinosaur like myself, because they did have an article on where some of the aircraft carriers from the US Navy were going to be discharged. And so they thought, oh, this would be a great opportunity to build buildings for emergencies. And I think this process and this project kind of really amplifies that we can rebuild quickly when we need to. And this process that you guys have established is fantastic. So thank you guys for sharing that tonight. And the other point I wanted to say is, again, how you guys are becoming educators in this whole process. And I think as we move forward, we need to constantly educate our clients and everyone around. And you guys have done that great. And I think, again, the 150 plus people that got to see and touch and feel what you've done is magnificent. So kudos to your team for doing that. Again, just a simple thing too. Again, you've got your kit of parts, and if one happened to mix, you said your roof parts where they could be put together, and if one got mixed around, again, they're all just a kit of parts for the roof. So that was a pretty cool highlight. Lastly is just want to say that in my breakout room, there was some extraordinary people that I just want to give kudos to. Louisa, who is like many of you that show up to all, or if not most of your events. So I thank you for all the people that are out there today that come to our events on a regular basis. I want to thank Mark, who is in Sydney, Australia today, who is a builder, and we need more clients that are getting into this. So thank you, Mark, for joining us from across the pond on your Thursday morning. And then Cameron, who is I got to double check your facts there, Cameron, but he is the first certified Passivhaus consultant in in Nebraska and
Arkansas,
Oklahoma. Thank you. You know what? I made a note here, but I scribbled it down. I can't even read my own writing. So Cameron, thank you for joining us. So great stuff, everyone. Thank you for joining us. Let's dive into the questions. Jeff, you get to kick it off.
Okay, so this is fabulous. I have a quick question. The question I have, though, is that who does the actual fabrication of the panels? And are there like list prices or price estimates per panel that you can use that integrate right in with the budgeting process? Because my impression is that all the panel modeling that you showed was done during schematic design and not during sort of detailed design or construction drawings, which I think is fabulous. So that's the question.
Do you want me? I'll take a stab at that on portions of it, Edie, and you can do sweep. So Jeffrey, that there are like unit pricing for each one of the components, and so that's what allows really for us to be able to provide consistent pricing for the components themselves. There is still the install portion of it, which is because of the nature of like the optimization of the components, can only be done to a certain point. There's structural requirements that are needed every project is different so it's connections, as well as different configurations require internal beams opposed to a slab on grade, opposed to a post and beam. So there's always site aspects of it that'll impact that cost. But B.Public can tell you what the component costs off the shelf. So that's one sort of for the object itself. And then for the install overall in the project, there is more variability that gets estimated early in the project and then gets refined as the project engineering or architectural work goes along. So that would be. And so in terms of manufacturing, B.Public's approach to manufacturing has been to actually connect with other like-minded organizations that are actually focused on prefabrication. And so it's like working with the farms to bring that produce to grocery stores in a lot of ways. It's a really great metaphor for it, that there's a lot of inconsistency in the economics of construction. But if B.Public is really working on seeing if we can have a demand for more consistent products so that manufacturing and so forth can happen more consistently throughout the year, and also at decentralized manufacturing locations. So there could be a shop that's able to create, some within one region, and then there's other demand in another region. That product is coming out of a different shop. And collective carpentry is our primary, partner our primary partner for manufacturing and install now, and they've been really great to work with. So.
Okay, so you do have a set of plants that build your components.
There are different manufacturing shops that manufacture under license from us to the specifications. Yeah, that's right. Yeah,
that's great. And it's good to see again. You and I had a conversation outside the PHI conference, I think, in New York last spring.
Yeah, I have to say, I have to start coming to these events a lot more often because I like a lot of you guys. Like this is.
I think it was you. I'm not quite sure, but it's pretty sure it was. But I have a million more questions, but I'll give it back to the gang, and because I'm sure they'll cover them as well.
Thanks, Jeff. We'll put you back in the hopper, and Jonah, we like you too, so please show up more often.
Oh, shucks.
All right, Mackenzie, over to you.
Hi. I think you partially answered my question here already, but I was curious if you fabricate panels with different assemblies based on different climate zones, with vapor barriers and air barriers and insulation depth, depending on the climate, or is it strictly in California?
No, I don't want to get anybody angry by saying it'd be really easy if we just worked in California necessarily. So, but our assemblies really were, they go up to an R50, 55, something like that, a little bit higher than that. So but one thing that we found, and this is neat, it's like really in any assembly, and this is the best practices of passive house, right? That air tightness has a huge impact on something. Captive air spaces has a big impact on your overall performance. Eliminating thermal bridges has a big impact. These are all like 30% increases. And at the end of the day, then those are the things that make your R value work well. Right. And so all of our assemblies have a similar or identical attention to those primary things. So thermally bridge free, captive air spaces, a good weather barrier, and air tightness. And then the R value just sort of can undulate within there, and that there's a lot of economy once you've addressed those primary technical aspects of it, like the cost between an R35 B.Public wall assembly and an R52, so a 40% increase, is only like an 8 or 7% increase in panel cost, because it's really basically void. It's just additional R value, because all the other layers are still there, whether you're R35 or an R52. And so I'm not sure if I answered your question, but so yeah, serving like within our mountain climate at like 10,000 feet, typically we're using an R55 or an R60 wall in our climates. And so, yeah.
And Sydney, I'll drop a PDF into the chat that you can grab, or it's downloadable off the website. So we have one floor panel that's an R51, but for the walls, we offer R35 or R52. And then for our top panels, it's an R59 or an R80. So with, that variety, we can address quite a, climate zones 2 through 8 with some flexibility. And again, with sort of predictability of costs and being able to, iterate the design, whether you're, modeling, we're not certifiers. So we're always working with, if you're going to certify a third party. So providing that data so that if you're modeling it, you can optimize. And then of course, look at what your systems are going to be, but that very early on, almost at that, napkin sketch or the schematic, you can get a sense of what would be the cost right then. So and we can iterate that estimate all the way through the design process until you're ready to order, rather than it being a surprise at the end of the project of, oh, we're not going to hit what we need for that climate zone.
And from a building science perspective, I think, and I didn't articulate this very well at the beginning, but so all the assemblies are very vapor open. So they're very resilient from a condition application. So it's the same wall assembly that we're using in that California Santa Cruz climate as we would in a multifamily at 7,000 feet here in our range. So it's so the building science, they're very resilient in that way. And that's I think there's some positive reinforcement, like when you're going through vapor open assemblies, that they tend to then utilize more sustainable materials as well if you're requiring a material to be vapor open. And so there's a lot of positive impacts from stemming from that vapor open approach to high performance. It's very resilient.
On that whole point, again, if hopefully you all watched last week's episode with Chris Magwood, and he talked about the material carbon emissions. So I think we're all on board with making sure that we're managing our operating energy and the embodied energy of the material. So we're over to Scott.
Guys, thanks so much for the presentation. It's awesome, of course. I'm gonna scooch back so the blur works for you, so you can see our assistant here. All right, technical details here. Look, we're just curious about how the pieces come together. Looks like you sealed the little blocks by themselves, so it doesn't seem like you can actually just automatically attach them like you would if you were framing something. So I'm just curious what that connection is.
It's part of the approach to the resiliency when it comes to structural loading. So the components are consistent, with the exception of that we'll have sometimes custom shear panels, or that'll need certain additional shear capacity or bearing capacity. But for the most part, the panels are consistent, but every building loads are different. So whether it's 3 stories in seismic or in wind, or 1 story, so that's always different. And so you saw a slide there that showed sort of the exploded view of the different components, and then those assembly details that you saw on the left. That's the opportunity for the structural engineer to specify what that connection is between the components. And for the most part, and this is really, so when we talk about rapid change, one of the things that we really identified was that we're not going to reinvent the wheel, the construction industry, as quickly as we needed to. So our assemblies are aligned with prescriptive light frame construction codes and so forth too. So there's a lot of the prescriptive information we're able to utilize. It's reducing how much any special inspections may be required because we're following that. And so that also then allows us to utilize standard Simpson ties or Simpson connections, which they're an amazing resource that has basically been designed for the light wood construction industry or prescriptive code. So we're able to utilize that. So on those standard details that you saw, that's the opportunity where the structural engineer or the project engineer of record would specify, okay, I want an LTP5 bracket at 24 inches on center on vertical seams, and I need this bracket here. And so we have all of the structural connections are exposed on the exterior so that the jurisdiction can come and review that after prefab is installed and look like your general contractor is, quality control with B.Public is, or the collective carpentry who installed it. Like there's lots, it's a lot of benefits to having those primary structural component or connections exposed in that way. So
cool. All right, thanks so much.
Mm-hmm.
Thanks, Scott. At this time, we should probably head over to Zach to talk about sponsors. It's a little early, I know, Zach, but just worrying with time. Sean Rose had a question, and over to you, Zach.
Okay, all right, sorry. I already talked about sponsors, our fabulous sponsors, so I'm going to go straight into just some quick announcements about what's coming up. Right now on the podcast, we have an interview with Luke Kellett of Kellett Design Group. This is an interview with Matthew Cutler-Welsh, who's the co-host of the Passivhaus podcast. Luke is a practitioner in Western Australia, so it's really interesting conversation about adoption of Passivhaus there and challenges around dealing with the vernacular of brick construction and ideas for getting around that. So please check out the podcast to hear that interview. Tomorrow or Friday, we have this great virtual tour. Well, it's a live tour in person by Michael Ingui and Amy Faea and Kevin Brennan at this site that we can watch virtually. So it's of the Engine 16 Passivhaus retrofit in Manhattan, retrofitting this firehouse into a multifamily building there. It will be part of the kickoff to the International Passivhaus Days. So Ken Levinson of the Passivhaus Network will be there to talk about the open houses that are happening around the United States, and Carl Hallbach of International Passivhaus Association will be talking about the video tours that are available to all of us that we can watch tours of projects around the world. So please join us on Friday. On Tuesday on Construction Tech, we have the tiny mobile Passivhaus office. This is going to be a presentation by Dan Welch of the Bundle Design Studio. Mackenzie Stickney, I think, who is on this call, is probably in this office as we speak. So we're really excited to learn more about this cool space and some of the challenges around doing tiny Passivhaus and how they overcame them. Super cool project. See you on Tuesday for that. And the next Wednesday, we have the Willow Heights Passivhaus retrofit. So this is also with Michael Ingui, a really cool row home retrofit in a landmark district in Brooklyn. So please join us next Wednesday to check that out. That's it for me. Thanks.
Thanks, Zach. Thanks for the events. Lots of great stuff coming up, especially the International Passivhaus Open Days that will kick off this weekend. So you'll be able to travel the world, look at a whole bunch of cool Passivhauses. So, so Sean Rose, you got your answer solved, but both B.Public and Collective Carpentry have an amazing Instagram feed and social media. So go there, like them, follow along. You'll see more of some of the shots that are not in the presentation night from their feed. So check that out. So in the hopper right now, we still have Kevin, Andreas, Steve, Ian, Dave, Eric, and Jeff. So first off, thank you for putting your info in the poll. It's great to see where you're located, your experience. We appreciate all that input. So that helps out with future shows that we're trying to create to ensure we're taking care of all of your interests. So thank you for that. And it is the end of the hour. So if you need to leave the showcase to go to other things, you can. However, we still got lots of questions, and I'm going to keep Edie and Jonah here as long as we can to get through them all, and JD. So good night, good morning, wherever you are, and we'll turn it over to the after hour. So back over to Kevin. Fire your question at the B.Public team.
Hey guys, great presentation. Amazing project. I've always had an opinion that we should always try and take a negative and turn it into a positive. And you guys totally took a project that was devastated by fire and made it into something better. My question really is based around what did you do to make it fire resistant from the outside? I do believe that our modern day danger in construction is not so much fires from the inside, but fires from the outside, neighbors garbage cars, things like that. What did you do to add resiliency to that structure? And then was this project certified, and did it have any blow door numbers? My standard 2 questions as well.
Sorry, JD, I think you should probably answer the one on fire from a design perspective. We haven't done the blower door test yet on this project. I know this will be a shock during these times, but the windows were delayed, and so they're not in yet. So, but there is so much to be done from a design perspective, like unrelated to Passivhaus as well, but in related just to design. So I'll let JD.
Yeah, in terms of fire resistance, it really just came down to cladding selection for them. So you saw some of those options in the presentation. They ended up picking cement board panels and corrugated metal for the cladding, but there were other options we explored. That just seemed to be that was kind of the right price point for them, and we are exploring kind of in future projects, and Jonah can speak more to this, but getting our assembly an actual fire rating, and looking at how that would apply in larger multifamily applications. But that's how we addressed it for this particular project.
There's a couple, like, because the assemblies are intended to have open rain screens too, like, or not necessarily open, but a back vented cladding, that there was like it's a screened core event basically that's designed to respond, and I would mess up the technical term for the paint, but it basically reaches a certain temperature that it foams up and closes those vents down. So there were a couple little technical hurdles like that when we do want venting with something, but we don't want it to be a spark cavity that needed to be addressed. But the other ones are just reducing crevices. So they're reducing eaves and or exposed eave framing, more parapets. All those things really do increase the overall fire resilience of the design itself beyond just the materials. So yeah, and windows and doors, I think having that higher strength windows and doors to resist against those higher temperatures is also important.
Which windows did you guys go with?
I think these used Alpine.
Yeah, that's correct. The Alpine Tyrol series were the main windows used on this.
Cool, great project. Good luck.
Thank you.
Thanks, Kevin. Appreciate your questions as always, and I will probably keep those as standardized questions. So if you don't make it, I'll be like, "Oh, here's Kevin's standard questions," and I'll fire them off to the guests. So thanks, Kevin. Steve unfortunately had to leave, but his questions were: what were some of the air sealing details? Who's responsive for them, and who has to guarantee in the process of reaching the right blower door score?
I'll take a stab at this one too. So the air tightness within the panels themselves is exposed on the interior. We're utilizing Intello for it. And so, and in this circumstance, it was the install crew that's taped off all of those seams. One thing though, that we are, we're having to not necessarily contend with, but need to address from that in terms of what language B.Public uses to convey the airtightness expectations. So in this circumstance, it wasn't B.Public or anybody else that would be on the hook necessarily for the airtightness when they did the slab, right? And so we can't necessarily guarantee an airtightness for the building if the installers aren't responsible for the entire airtightness assembly, and which relates to not just the slab but also the windows and doors and other penetration details. And so one thing, we are very confident within the performance of the assemblies that we're providing the airtightness on, and really our approach to the other aspects is from an educational perspective. So when you saw in some of the information that JD showed, that we're really trying to provide what are the standard penetration detail, both for our assemblies and other people's assemblies, as well as just an understanding of what's the intention there. And one thing you'll see in our standard window details, is that it first talks about where are you installing your window first, and those are different considerations. So we're trying to leave those decisions up to the client and the builder, but try to give them good information to base those decisions on. So.
Great, thanks, Jonah. Oh, go ahead.
No, I was just going to say, we're always targeting below a 0.6 ACH because we typically are certainly on this project, it's utilizing a Zender ERV system. And so we are very much investing in the airtightness of the building so that we can recover as much energy as possible by putting it through that balanced ventilation system.
Yeah, and I'll just reiterate kind of what you said too, is the fact that you guys target, the big task that makes for designing and modeling relatively easy because you've taken care of thermal bridges. And I know Enrico at EMU talks about elephants, more of the thermal bridges, but I think the same thing too is you keep thinking of the big elephants, then when you get to the mouses or the mice, that it makes it a little easier. So again, great point with that. So it looks like
just one other point on that Sean, we, that airtightness layer on the interior, right? It's really kind of sacred to us. We don't want to penetrate it, but it's one of the reasons that our assemblies are also focused on that captive airspace within the different cavities, that even if you do have air leakage within a single cavity, because people are going to hang pictures, people are going to put in doors and things like that. And if we're building to 100 years, then we need our assemblies to be okay with that as well and so forth. And so the air tightness, the primary interior air tightness is your first sort of defense. Your next one is the captive spaces within that insulation, as well as using dense packed cellulose, which is reducing that convection and so forth. But then the other one is, and we recently had the good fortune of being able to test our weather barrier ceiling on a building. So we had a failure within certain sections of our Intello, and we were testing our weather barrier to 0.72. So that, so even if your air tightness layer, is failing, then, the other layers are also building in a lot of resilience. It might not be meeting Passivhaus requirements, but really Passivhaus is coming from a performance, optimization perspective ultimately. And we really do try to keep our eye on that. So.
Lots of great points. You pretty much just said my entire phone-free presentation that I give with 475. So thank you for that. Yeah, it looks like Kevin stole Ian's question. So we're going to go over to Dave Smits. Dave, are you still with us?
Yes, I am. Thank you. I'm interested in hearing a bit more about B.Public's mission and vision. As I went to your website tonight to learn more about your company, it's obviously the project's fascinating. You do fascinating work, but I'd like to understand a little bit more of your of that part of your business, sort of what you're targeting here in terms of affordable passive house and that sort of thing, because that's what I understand it to be. But I'd like to hear more from you, please.
Thanks, Dave. Yeah, we're different in a lot of ways. I don't know how many people are familiar with public benefit corporations, but it's sort of a merging of nonprofit and for-profit, or it's a triple bottom line that we're really designed to serve people, planet, and profit. We do have a mission and a vision, and yes, our goal is to make passive house or passive house-like performance and carbon sequestering available to any project of any size. And so it's really about accessibility and also, driving the cost down. It is still very precious for a lot of people to reach for a better building envelope. And by simplifying and offering our kit of parts for very, what we see as very usable, functional shapes to build, from ADUs to multifamilies, it allows us to offer to many more builders, many more projects, this type of performance. So it is sort of an equalizing of an offering to a larger audience. And I think tonight's been really interesting, to serve the market. We do offer design services. Obviously, we've got architects on staff, but we're really here to serve builders and designers and architects to specify when projects can and use a standard kit of parts to do so. And this will not be surprising to anyone on the call. Most of the projects we are doing, especially with architects, we're maximizing those standard components and using all of our IP and all of those shop drawings as much as we can, and then using custom or site built, some hybrid, to get all the way through to a project. So being able to use those optimized elements to make a project more accessible to high performance, rather than, as we all know, getting to that question of, is it going to be high performance, or are we going to go just with code for the budget and it gets thrown out the window, right? We want to put it inside the building, nice and warm and safe in the decision-making process from start to finish. And truly from very small scale projects to, single family to multifamily. That's really what we're about, is just opening it up. So we spend a lot of time hanging out with these cool people, right? I mean, truly, this is our place, but we also spend a lot of time talking to people who have never heard of Passivhaus, who are just looking for better options and are excited about, low energy, or they're looking at recycled content. And, this client that we saw the project tonight is a perfect example. They were very well researched, really dedicated to Passivhaus, and they came to us because they were going down a road and they realized that they were looking at an assembly that was filled with foam, and they didn't want that. They were very dedicated to a foam-free solution that was Passivhaus-like, that they could really live with. And I feel like people rebuilding after losing homes, their heart is in it. They're also making decisions from a different place. So similarly, we talk to a lot of intentional communities, co-housing developers, and same thing, people who are really like-minded, who have already made some great progress in decision-making, and we become a really easy solution for them because we can. Right, we can help along a builder who's never done anything to this level and get them a lot of the way there, and then share with them our details for penetration and educate them to get them all the way there. So we're doing a lot. Thanks for the question, Dave. Did that cover it for you?
It did. Thank you very much.
You bet. Thanks for visiting the website.
And again, I encourage all of you, if you haven't been there, go check it out. There's lots of great stuff they've got there, including all these free downloads. So Eric Reinhardt, are you still with us? Eric, it's over to you.
Hey, yeah, I'm here.
Great.
I'm sort of, I'm always interested in details, and it looked like you probably had to think about that a lot with this. So I just wanted to give you a chance to speak more about the joints and the sort of issues you had to consider when you're considering shipping and assembly and quality assurance and the whole 9 yards. So anything you want to talk about there, I'm glad to hear it.
Yeah, I'll say that it's that we're still thinking about joints and connections. And so I think that'll be something that happens consistently. We notice that every time something you address something, your magnifying glass gets a little bit bigger, right? A little bit sharper, and you get onto the next issue. Right now, our first ones were mostly our biggest sort of R&D decisions were mostly related to thermal bridging first. Like that was an important part that we really wanted to have, to really sort of take thermal bridging off of the table when it came to designing with the components. We didn't want to have to say, okay, well, you can put the components together, and depending on how many of this intersection, you need to sort of downgrade your performance. And so what I'm happy to say is that the more intersections and angles and corners that you have in the assemblies, actually the better your project is performing, period. Like, so that's a nice one. The other one was from a structural connection perspective, in that constantly is increasing or is adding challenges, because we have when we put a product out for download, as you can imagine, the amount of conditions that the general public can invent to put those pieces together is pretty amazing. So it's really being vetted by the general public at this point, as well as our structural engineers, who are partners in the R&D process, but they're also the project engineers for a lot of projects across North America that are utilizing the components as well. And so they're being faced with sort of new asks as well. And so one of the things that we see is, it's not necessarily an issue of how to address that problem. How do we address, like, how much do we want to address that problem? Because you can address a problem by eliminating the situation as well, right? And so we can say, like, well, we're just going to establish a parameter where that condition doesn't exist, say. That's one option. The other one is, okay, so how can we provide a solution that's predictable? Like, and sometimes, you know, that condition might be an issue for manufacturing. It could be one from performance, from the continuity of the structure, weather barrier, or air barrier. You know, so it could be any one of those. And those are all really different. And like, even when you nail one condition, you're always looking for, okay, how could we do that more easily? Like, when can we just offload a set of components and anybody be able to install them, and for B.Public to have confidence that their performance, both structurally and from a building perspective, are they going to work? And so that's our goal, is to be able to do that. And we just keep on it. Like, there's always fun problems to solve.
Well, if I could just make a small follow-up, is there like you have to put a lot of instructions along with the package for the installer to be sure that they're going to get it right, or do you give them like a little training?
Well, that's something that we're working on now, more to be able to open up the installer network. But currently, the Collective Carpentry, like, who, an example, installed this last project, they're like intimately familiar with the components and so forth. So they're also the greatest opportunity or partner for us learning about how easy that install goes. Because they're invested in that long-term solution, because they know they're going to have to install more of them, right? And so every good feedback or feedback that we get from the field from them is really important to us too. So I think probably what we want to do is we want to keep on moving down the path of simplifying and refining those connections in the materials that are used to achieve them, to the point where we are able to have, very simple Lego or IKEA-esque instructions for that, for those connections. But I think, as most people know from a design side here, it's you can't control really how people utilize a component once it's left your hands, period. All you can do is just really give them the best information possible to utilize them to the best of their own advantage.
Thanks, Eric. I think, Jonah, thanks for summing that up. I'm going to switch things over to Zach because I'm at a construction event that's going to get started. And of course, you can tell I'm there because look at all the trucks in the shop here. So, you know, there's a lot of builders at this event. So I'm going to move on. I'm going to pass the torch to Zach. Thanks, Zach, for filling. Edie, Jonah, and JD, and the rest of your crew, Charlotte. Thank you very much for doing a kick-ass job of what you do. It is great to connect with you guys always. So enjoy your night. Zach, you have Jeff, Sarah, and Ian in the question hopper.
Indeed. Thank you, Sean. As always, we'll miss you.
See you guys next week or Friday.
That's right. At the tour. Fantastic. Okay, I think Sarah is up first, actually. So Sarah Bayer, I know some of these questions may have been answered, but they're really good ones, and it'd be great to hear it on the in audio, not just on the chat. So.
Hey, yeah, I think I got some answers, but maybe a little more detail. So I have a bunch of them, but I'll start with the one that's not answered yet, which is, have you guys looked into providing exterior reclad Lego panels and Lego-ish? Everyone loves Lego. And do you have EPDs for your panels? Along with that, have you done like embodied carbon calculations type things, and what did you use to do that? And maybe a little more detail about overhangs and porches. Thank you.
Thanks, Sarah.
Yeah, I might be lucky enough. What was the first one? What was it? I'm sorry.
Exterior reclad, overclad.
Oh, yeah, we're not, just because there's a lot of really smart people working on that. And so we're focused more on scalable new construction, so from small to medium. But there are some really good people working on the retrofit thing that I certainly do believe is really critical, and I know everybody at B.Public feels that way, but we don't have anything that's appropriate. Our assemblies are all structural as well. So, and then your next question related to environmental impact, and to date we've only done empirical analysis internally, and we are in the process of having that done externally too by a third party for our own data driven decision making when we look at material sourcing resilience as well, but we haven't done it from a third party yet. And I think one of the reasons is that we're still refining and seeing what our material sourcing is from a consistency perspective, because that will really have a lot of impact on what that final carbon input would be.
Can I jump in for a sec on that? Because we've talked to a lot of LCA folks and looking at the best approach. We're not technically a product, right? We really are off-site construction, and so it is an assembly. So it would be reliant on the materials and the manufacturers of those materials to provide those reports to us. But we would really go the LCA. So we're looking at the life cycle of the total assembly. And one thing that we haven't really talked about, but we've talked about sort of the decentralized manufacturing. In part, that is because we always want to be looking at the impacts on what's locally available and locally sourced. So to be able to adjust, maybe our dense pack cellulose manufacturer based on that location is really important to us. That fluidity of sourcing and being able to have that resiliency. We've all seen some interesting material shortages, and we're really geared towards that building science. So in some ways, dependent on what's happening in supply chain, that we can swap out, for hemp or something else and still deliver panels that are going to last for, a couple hundred years and perform is really important to us.
Thank you so much. Really love what you do. Yeah.
Thank you.
All right, thank you, Sarah. Okay, so next up is Jeff. I think Jeffrey, I think this may have been a question about contact info. Maybe you already have it.
Oh, I was just asking if they could just throw it on there for the chat. That's all.
Yeah.
So to B.Public A, if there's, how do we contact you, to your preferences?
Great. You could just put that into chat if you like, Edie.
Yeah, thank you, Jeffrey. And I'll put it again too,
Okay.
offering to everybody that we generally offer one weekly free, of course, onboarding for professionals. And it's always on our contact page, and you can just log in and reserve space on that. Right now, they're scheduled on Fridays in the middle of the day. We've tried other days of the week that haven't worked quite as well. Friday seems to be a time where people can do that lunch and learn. If your studio or you have a group of people that want to do it, we certainly do the tech onboarding a couple of times a week, and we're happy to schedule that. And that really is a deeper dive into the SketchUp and into the panels themselves. And we try and keep it small enough so that if you have a very specific question or you've sent us something to model, that we can have a back and forth. We don't generally have 62 people on like these lovely events. And I'll put that in the chat link as well for signing up. Thanks, Jeff.
Great, and I think we've got one question left, and that's Ian.
You mentioned, I think, a reference to Intumescent Paints, and I was surprised that you'd found one that worked on the exterior, because I haven't found any, so I was curious.
I think that was me. I think that referred to that, and I can't necessarily vouch for it, but it must be because it was being applied by the manufacturer to a vented, to like a screened vented core.
Okay.
So
maybe it's pseudo outside or something like that allows it to work in that case. So.
Yeah, and that's what I was wondering too. If it maybe it's because it's protected and not just exposed to rain or UV. I'm not sure.
Okay, I've asked the same questions and not had a good answer, so I was interested that you might. So cool.
Yeah, the condition that we were using it was it's planned to be used in the Little project is in a protected situation. But that community is very fire intelligent, as you can imagine at this point. And I'd be happy to reach out to the builder. And it was something that he was sourcing locally, and to get that information, and you can see if they do have an exterior product.
It's prevalent in so many different installations, so it's also not that costly. It's a few grand for a house, and it's kind of like if it doesn't seem imprudent for a lot of situations.
Yeah, we used it a lot in trade shows. We paint everything with it in trade shows, and I can certainly attest to its functionality. It's amazing what it does.
Fantastic. Thanks, Ian. Thanks, Jonah. So JD, Charlotte, Jonah, Edie, this has been really fantastic. What a great project and inspiring work at B.Public. I think all of us just really come away kind of blown away about what you guys are doing. So we really appreciate that you've come here to share it with everybody. Yeah, so with that, have a great week, everyone. If you like to join us on Friday, we'd love to see you at the virtual live tour of the Engine 16 project in New York, and of course next week on Construction Tech and the showcase. And be well.
Thanks so much, Zach.
Thanks everyone.
Thank you.
Have a great night.
Yeah. Take care.
Thanks everybody for coming. Really, it's nice.
Yeah. Awesome. Bye-bye.